All right, so let's take a look at an application problem with mortgages. This actually coincides with problem 12 in the online homework. Some new things we're going to look at is number of payments and interest paid during a specific year. So here's an example. What we're going to do is look at a $260,000 mortgage house. We're going to make a down payment of 20%, and the rest is going to be financed with monthly payments for 30 years, just like normal, with an APR of 5%. So, first thing we have to do, part A, we're going to try to find the size of the monthly payment. Fairly routine question for us. The first thing we have to do is figure out how much we're borrowing. Well, our down payment is 20% of the 260,000, which remember is 0.2 times 260,000, which is $52,000. So we have a nice down payment there. And then what are we borrowing? Well, we take the 260,000 minus the 52,000 and end up with 208,000. So that's what we're borrowing. And then from there, we go to the appropriate annuity formula. Since we're making a lot of payments, we use an annuity formula to figure out the payment. We want the one with the negative exponent because it's a loan. We know we have 208,000 now. We want to know what the payment needs to be in order to pay off the loan in 30 years. So we have 208,000 is equal to, we don't know the payment size, so we call that P. 1 minus, now, our APR was 5%, so that is 1 plus 0.05 over 12, and we're making 30 years of monthly payments. That's 360 payments. So again, a fairly typical calculation that we've done several times. So after using technology to get this, the payment size should be $1,116.59. So there's our payment. Now for part B. The balance after the 120th payment is made. So there again, we have to kind of visualize what's happening. You might remember, if this is payment number 120 and we have 360, we want to know the balance here. And that is equivalent to saying, well, what is the balance? Now that I know what payment I'm making, what is the balance that all those payments of $1,116.59 would pay off? We know that that is the same annuity formula. But now this time we have 240 payments to go. So 1 minus 0.05 over 12. 1 plus that to the negative 240, because that's how many we have to go. And if we compute that out, that should be $169,191.49. So what that means is that's what we would have to pay off right after making that 120th payment to pay off the loan. And again, notice it's a lot more than what we might expect. But remember, with all that interest and whatnot, every payment that we make has a portion that goes toward the balance and a portion that goes toward the interest. And that's one thing we did discuss in class as well. Now, something that's new, so this one requires a lot of steps, it seems. But we want the interest paid in the 10th year. So let's just think about how every year is divided up. If I look at the first year, in the first year I have payments 1 through 12. In the second year, that takes me up to payment 24. So if I look at the 10th year, that takes me up to payment 120, and the one that had just happened was 108. So what we want to know is, what is the difference between the balances? That's one thing we can figure out with annuity formulas. So we already know the balance after payment number 120. We want to know also the balance after payment 108, which means there's 252 to go. So that is 111659. All that thing we're so accustomed to by now. It's a long calculation, I know. And that should give us $173,999.77. And yeah, we will leave that all there just because we want it to be accurate. So now the difference in the balances, and we find that because we know what the balance is after payment 120. We know what the balance is after payment number 108. If we subtract that, we figure out, well, how much did we actually pay toward the loan in that year? So it's 173,999.77 minus the balance we just got, which was 169,191.49. And that difference is 4,808.28. Now, one way to compute interest, we know, is to figure out, well, how much did we pay and how much did we actually owe? We actually only owed 4808.28 in that year. So the payments in our 10th year would be 111659, and we made 12 payments that year. So that comes out to be $13,399.07. So finally, the interest in that year, if I can spell, is equal to, well, let's take a look at that. Here is what we paid. And there is what we actually owed. So that means the rest is interest. And that final figure is $8,590.79. So there is the answer to Part C. So all of that is how you would do Part C on that problem. In the next video, we look at Part D, how to find the number of payments, and that we're going to use Excel for. As explained in the video, we don't want to use logarithms because it's not a required component of the course, but that way we get to see how technology works too. So I thank you for watching, and hopefully you can watch Part D as well.